Imagine a desert so vast that it could swallow entire countries, a golden ocean of sand stretching endlessly toward the horizon. Now imagine moving billions of tons of that sand, grain by grain, in one of the most audacious engineering projects the world has ever seen. This isn't science fiction. This is happening right now in China's deserts, and what you're about to discover will change everything you thought you knew about what's possible. The question isn't whether they can do it, it's how they're pulling off something that seems physically impossible. China faces a creeping environmental catastrophe. The Gobi and Taklamakan deserts are expanding at an alarming rate, approximately 3,600 square kilometers every single year. That's an area larger than Rhode Island, disappearing under sand annually. Over 400 million people live in regions threatened by desertification, their farmlands slowly suffocating beneath advancing dunes. Here's the shocking reality. Nearly 27% of China's total land area is now classified as desert or degraded land. Agricultural productivity in northern provinces has dropped by up to 40% in affected regions. Ancient cities that once thrived along the Silk Road are now buried beneath meters of sand. The economic cost, an estimated $54 billion in lost agricultural output every year. But China has declared war on the desert. Their weapon, a revolutionary approach to sand removal and desert management that combines cutting-edge technology with massive infrastructure. A project so ambitious that it involves relocating billions of tons of sand to literally reshape the landscape. Before moving a single grain of sand, Chinese engineers faced an impossible puzzle. Where do you even begin when dealing with deserts the size of France? The planning phase took over 5 years and involved satellite mapping of unprecedented detail. Using LiDAR technology and AI-powered analysis, scientists created 3D models of over 200,000 square kilometers of desert terrain, identifying priority zones where sand removal would have maximum impact. They studied wind patterns dating back 50 years, tracking exactly how and where sand migrates. The site selection process was ruthlessly strategic. Engineers identified choke points, areas where removing sand could prevent larger dune formations from advancing. Think of it like stopping an avalanche before it starts rather than trying to clean it up afterward. Environmental impact assessments took another 2 years. Scientists needed to understand what happens when you remove billions of tons of sand. The legal framework alone required 127 different permits and approvals, but the real challenge was still ahead. To move a desert, you need machines that sound like they're from a science fiction movie, and that's exactly what China built. Enter the Sand Dragon, a custom-designed excavation system unlike anything used before. These aren't your typical construction excavators. We're talking about machines weighing over 800 tons, standing as tall as a 5-story building, equipped with specialized vacuum systems that can suction up to 6,000 cubic meters of sand per hour. To put that in perspective, that's enough to fill 2 Olympic swimming pools every 60 minutes. The conveyor systems are engineering marvels themselves. A network of modular, weather-resistant conveyor belts stretching over 400 kilometers, a silver ribbon cutting across a sea of gold. Each belt section is made from military-grade polymers that can withstand temperatures ranging from -40 degrees Celsius to +70 degrees Celsius. Why such extremes? Desert temperatures swing wildly between freezing nights and scorching days. Then there's the stabilization technology. Chinese engineers developed a proprietary biopolymer compound, a kind of liquid cement that gets sprayed onto exposed desert surfaces after sand removal. This substance creates a protective crust that prevents sand from blowing back. It's biodegradable, allowing vegetation to eventually break through, but stable enough to last several years. The filtration systems are equally impressive. Massive screening stations separate different grades of sand: fine particles for construction, medium grades for land reclamation, and coarse materials for creating artificial barriers. Nothing goes to waste. Construction began in 2019 in the Tengger Desert, one of China's most challenging environments. The first challenge? Just getting equipment to the site. Engineers built 200 kilometers of reinforced access roads capable of supporting vehicles weighing hundreds of tons. The foundation work was extraordinary. Before installing the massive sand dragons, teams had to create stable platforms in shifting sand, like building a house on an ocean of quicksand. They drove steel pylons 15 meters deep, filled with concrete, creating artificial bedrock. Over 10,000 of these pylons were installed in the first phase alone. Installing the conveyor network required military precision. Each section had to be perfectly aligned. Even a 1-degree deviation over 400 kilometers would mean missing the target by 7 kilometers. GPS-guided robotic systems placed each support tower, while engineers monitored alignments in real time using satellite data. The excavation process itself is mesmerizing to watch. The sand dragons work in coordinated teams of 4, creating systematic patterns across the desert. They don't just scoop randomly, they follow carefully calculated routes that account for wind patterns, preventing removed sand from simply blowing back into cleared areas. But here's where it gets really interesting. They're not just removing sand, they're mining it. Beneath many desert surfaces lie layers of different geological periods, each with distinct characteristics. Some sand is 10,000 years old. Some samples contain microscopic fossils that tell stories of ancient climates. The removed sand travels along the conveyor network to processing centers, massive facilities where automated systems sort, clean, and package the material. Some goes directly to construction companies for concrete and glass production. High-purity silica sand gets refined for electronics manufacturing. Lower-grade material is used to create artificial islands and land reclamation projects along China's coast. Water management presented another enormous challenge. The operation requires approximately 50,000 liters of water daily, not for drinking, but for dust suppression and equipment cooling. Engineers couldn't just truck in water, the logistics would be impossible. Instead, they installed atmospheric water generators, machines that extract moisture from air, producing up to 5,000 liters per unit daily. Even in the desert, there's moisture in the air. You just need the technology to capture it. The technical sophistication of this operation rivals anything in modern engineering. The Sand Dragon's vacuum system operates on a principle called pneumatic conveyance. Massive turbines create a low-pressure zone, essentially a controlled tornado inside the machine. Sand gets sucked up through reinforced intake nozzles at velocities exceeding 180 kilometers per hour. But here's the clever part. The system adjusts suction power based on sand density, preventing machine damage from rocks while maximizing efficiency on pure sand. Inside the machine, the sand passes through a multi-stage separation system. First, a cyclone separator spins the material using centrifugal force to remove rocks and debris. Then, electrostatic filters extract metallic particles and other contaminants. Finally, optical sensors analyze grain size in real time, directing different grades to separate output streams. The conveyor system uses regenerative braking technology borrowed from high-speed rail systems. When sand-loaded conveyors descend slopes, the electric motors switch to generator mode, capturing energy that gets fed back into the grid. Environmental monitoring happens continuously through an array of sensors. Dust particle counters ensure the operation doesn't create air quality issues. Seismic sensors detect any ground instability. Thermal imaging cameras mounted on drones patrol the entire operation, identifying equipment overheating before failures occur. An AI system processes data from over 50,000 sensors in real time, predicting maintenance needs and optimizing operations. Perhaps most impressive is the stabilization technology. After sand removal exposes the underlying surface, often compacted clay or ancient soil, specialized vehicles spray the biopolymer solution. This isn't simple spraying, it's precision application. The vehicles use GPS guidance accurate to within 2 centimeters, ensuring complete coverage without waste. The polymer penetrates the top several centimeters of soil, creating a mesh-like structure at the microscopic level that holds particles together while remaining porous enough for water infiltration. Quality control in an operation this massive requires obsessive attention to detail. Engineers learned quickly that desert conditions destroy equipment faster than any other environment. Initial trials in 2018 revealed catastrophic failures. The first-generation Sand Dragons lasted only 6 weeks before sand infiltrated their hydraulic systems, causing complete breakdowns. Engineers went back to the drawing board, redesigning seals and filters. The current 4th-generation machines have operated continuously for over 18 months without major issues. The operation has evolved dramatically through continuous optimization. Machine learning algorithms now predict equipment failures up to 72 hours in advance, allowing preventative maintenance that has reduced downtime by 60%. The results are nothing short of transformative. In just 5 years, over 2.3 billion tons of sand have been removed and relocated. That's equivalent to building 15 Great Pyramids of Giza, except they're doing it continuously, month after month. The reclaimed land tells an incredible story. Areas buried under sand for decades now reveal ancient agricultural terraces, proving these regions were once fertile farmland. Local farmers are returning to land their grandparents abandoned. The first harvests from reclaimed areas have been surprisingly productive. The soil beneath the sand, protected from erosion for decades, retains nutrients and moisture better than surrounding areas. Economically, the impact extends far beyond agriculture. The recovered sand supplies 15% of China's construction industry needs, reducing the need for river sand mining, a practice that was devastating river ecosystems. The silica extracted has become a key input for China's semiconductor industry. The project has created over 100,000 jobs in regions that previously had few employment opportunities. Environmental benefits surprised even the project's designers. With sand barriers removed, natural water drainage patterns are re-emerging. Ancient springs buried for years are flowing again. Vegetation is returning faster than predicted. Native plant species whose seeds lay dormant beneath the sand are sprouting, creating green patches in what was once barren desert. The social impact might be the most profound. Communities that were relocating due to advancing deserts are now staying, rebuilding. Schools that were closing are reopening. There's hope where there was once only resignation to the desert's advance. What you've just witnessed is more than an engineering project. It's humanity's refusal to surrender to nature's challenges. China's desert sand removal operation proves that with enough innovation, determination, and resources, we can literally reshape our world. But this raises bigger questions. If we can move billions of tons of sand, what else becomes possible?